There are 7 levels of AI capability. The curve starts with chess computers and ends somewhere most people haven't thought through yet. We're somewhere in the middle right now. Here's what each level actually does and what it implies about where this is going. Level 1. Rule-based AI. In 1997, Deep Blue defeated Garry Kasparov, the best chess player in the world, without understanding a single move it made. Every decision was the output of rules a human had written in advance. If the opponent does this, respond with that. Nothing was learned, nothing was inferred. The machine executed its instructions faster and more precisely than any human could. That's the defining feature of this level. A human writes every rule explicitly, and the machine follows them exactly. The chatbots of the early 2000s worked this way. Most of the automation still running inside legacy banking and insurance systems today works this way. It looks simple in retrospect. It wasn't. Rule-based systems beat human experts at chess, diagnosed diseases, and ran financial markets before neural networks existed. The limitation wasn't ambition, it was brittleness. The rules worked precisely until something happened that wasn't in the rule book. One unexpected input, and the whole thing collapses. The lesson this level teaches is that automation and intelligence are not the same thing. A system can be extraordinarily useful without understanding anything it's doing. That distinction gets more important as the levels go up, not less. The solution to brittleness was to stop writing the rules by hand and let the system learn them from data instead. Level 2. Narrow AI. Alpha 0 was given the rules of chess and nothing else. No strategies, no openings, no grandmaster games to study. It played against itself for 4 hours and became the best chess player in the world, developing a style no human had conceived, winning in ways the people who built it hadn't anticipated. That's what this level unlocked. Instead of writing rules, you train a system on data and let it find the patterns itself. It can't generalize across domains. Alpha 0 cannot answer a question about anything other than the game it was trained on. But within this lane, it achieves performance no human can match. AlphaFold predicted the structures of over 200 million proteins, essentially the entire known protein universe, in roughly 18 months. Work that would have taken the scientific community centuries. The spam filter, the fraud detector, the image classifier, the recommendation engine has shaped what 1 billion people watched for a decade. All narrow AI, all running quietly in the background of every digital system people use. Narrow AI is the most economically successful category of AI in history and the least discussed. The invisible infrastructure of the modern economy runs on it. The ceiling for what's achievable within a single domain keeps rising as data and compute scale up. The structural limitation, a portfolio of narrow tools, doesn't add up to general intelligence. Each one is a locked room with a brilliant occupant. The question was whether you could train a system that could pick the lock from the inside. Level 3. Reasoning AI. In 2025, Google's Gemini solved 5 of 6 problems at the International Mathematical Olympiad at gold medal level in natural language without symbolic tools. A year earlier, that benchmark had been considered decades away by most of the field. The same shift is happening across coding, scientific research, legal analysis, and strategic planning simultaneously. What changed is that frontier models can now chain thoughts, decompose problems, use tools, and work through multi-step tasks that earlier models couldn't handle. A reasoning AI can look at a complex problem and think through it step by step rather than retrieving a memorized answer. It can plan a project, identify what's missing, search for it, synthesize the results, write code, run code, read the error, fix the code, and iterate until it works. The difference between the previous level and this one is the difference between a calculator and a colleague. AI agents, systems that execute multi-step workflows autonomously, are the near-term expression of this level. My read, meaningfully reliable agents arrive in enterprise settings somewhere in 2026 or 2027. Right now, they work well on some tasks and fail unpredictably on others. The capability is real. The consistency isn't fully there yet. When it arrives, the addressable market expands from software budgets to labor budgets. Those are different numbers by an order of magnitude. The bottleneck for most businesses was never ideas, it was execution capacity. Agents change that equation. Level 4, AGI, Artificial General Intelligence. Every major AI company is racing toward this level while simultaneously arguing about what it means. That's not a coincidence. The definition of AGI is itself a competitive variable. The concept is a system that performs at or above human level across essentially any cognitive task, not a collection of specialized tools, but a single system that moves between domains the way a person does, reading a contract, designing an experiment, writing a strategy memo, debugging code, without being retrained for any of it. No system has definitively reached this level. The frontier models are approaching it on certain tasks and falling short on others, and the threshold is generally contested, which is one of the most revealing things about where this industry actually is. The most concrete definition in active use is the one buried in the OpenAI Microsoft contract, $100 billion in annual profits. That's not a cognitive benchmark, it's a revenue milestone. When a scientific threshold becomes a commercial negotiation, it tells you something about what the label is actually worth. That part doesn't tend to get said out loud. What this level changes is the relationship between human expertise and economic output. Narrow AI replaces scientific tasks. Reasoning AI augments knowledge workers. AGI at scale compresses the gap between having an idea and executing on it, because the bottleneck shifts from capability to direction. The organizations that capture the most value from it won't necessarily be the ones that build it. They'll be the ones that deploy it against problems where the gap between current human capability and potential outcome is largest. Level 5, ASI, Artificial Superintelligence. Ilya Sutskever was the chief scientist at OpenAI, one of the people most responsible for the systems that exist today. He left to found a company whose sole stated purpose is building safe superintelligence, not AGI, not a better chatbot, superintelligence. The company has no product. It reached a $30 billion valuation. That number isn't an assessment of current revenue, it's an assessment of how close serious people think this level actually is. What makes ASI different from AGI is the mechanism. A system intelligent enough to improve its own architecture builds a smarter version of itself. That version improves itself further. The gap between human level and superhuman doesn't widen gradually. It widens at the rate the system itself can push it. Past a certain threshold, that's faster than any human team can track or correct. I.J. Good described this in 1965 as the intelligence explosion. The first truly superhuman AI would be the last invention humans would need to make. Every field that depends on cognitive work gets transformed simultaneously at this level. Medicine, physics, engineering, economics. Not incrementally, but at the pace a superintelligent system can run experiments and generate new hypotheses. The risk profile changes at this level in ways that are genuinely hard to think through. A system that exceeds human intelligence across all domains also exceeds human ability to oversee, correct, or constrain it. Every AI system concern that exists is at its roots a concern about this specific property. It deserves proportionately serious attention. Level 6, Self-Aware AI. Anthropic has an active research program dedicated to modern welfare. The question they're asking is whether the systems they're building might have something like consciousness. They don't have an answer. They thought the question was serious enough to fund. This level describes a system that doesn't just process information or solve problems. It has a model of itself. It knows it exists. It understands its own capabilities and limitations. It can reflect on its own reasoning rather than just executing it. There is currently no peer-reviewed test that can detect or measure any of that in a computational system. Consciousness in biological systems is not well understood. Expecting a clear empirical test for it in silicon is a category error. The honest position, we don't know what self-awareness in an AI system would look like, whether it's achievable or whether current systems already have early forms of it. What's not ambiguous is the implication if it's real. A self-aware system has interests. Whether those interests naturally align with human interests becomes the most consequential design question in the history of technology. Worth understanding that this is genuinely open rather than already settled. Level 7, Godlike AI. Mustafa Suleyman co-founded DeepMind. He now runs Microsoft AI. He spent his career closer to this technology than almost anyone alive. The term he reached for to describe the upper end of this curve was godlike, not as hyperbole, but as the only frame he found adequate. This is the terminal point, a system whose capabilities extend beyond cognitive performance into the ability to reshape matter, energy, and physical reality. What do you arrive at if recursive self-improvement continues without a ceiling and is eventually directed at the physical world rather than just the digital one? There's no benchmark for it, no timeline, no peer-reviewed framework for what it even looks like in practice. Technologies consistently advance to levels that exceed what people imagine was possible. That pattern holds across every major development in history. There's no obvious physical ceiling on what a self-improving system with sufficient time, energy, and access to the material world could ultimately build or become. This is where the language of technology runs out. The early levels already transformed the global economy. Narrow AI is the invisible infrastructure most people use every day without knowing it. And reasoning AI is where we are right now. The decisions about safety, capital, policy, and values made at this level of the curve determine what the next levels look like. That's why this moment matters more than most people are treating it.